Hello Internet, today I'll show you the most common issues with L3 Antminer hashboards. One of the most frequent problems is the buck converter that converts 10 volts to 14 volts for powering the last two domains. There are ready-made boards available for plug-and-play solutions, but in most cases, repairs involve replacing resistors, diodes, or chips. The main culprit is often this resistor here, which oxidizes and loses proper contact with the board, or the entire board contact oxidizes and detaches. The resistor is 698 kiloohms, but any other within that range can be used as a replacement, typically a 680 kiloohm resistor. I'll also display a diagram showing the entire circuit. There's damage to the contact on the board, so we'll need to repair that as well to ensure the entire circuit functions properly. We'll use 0.1 mm wire to create a contact from the point where the damage occurred to where the old contact was, allowing us to solder the resistor onto it. While ready-made pads are an option, I prefer wire due to its durability and resistance to moisture. We solder the wire and use UV mask as an insulator and adhesive. We apply it over the soldered area and cure it with UV light. The best mask is the one that sets in 3 seconds, which we use because it has a better response to drying and tightens even underneath the wire, resulting in better adhesion. Sometimes, we need to apply the mask in multiple layers to ensure it has dried properly. Once everything is thoroughly dried, we use a scalpel to carefully remove excess UV mask until we reach the wire, which serves as our contact conductor. We then prepare it for soldering the resistor by applying a small amount of solder to it using the soldering iron. If the board isn't properly cleaned or if there's dust, flux, or moisture present, the mask won't adhere well to the surface. That's why we clean the board multiple times with 99% alcohol and a clean cotton pad or lint-free paper towel to ensure no residue is left behind. We take care when soldering the resistor, preferably using a soldering iron rather than a hot gun, to minimize damage to the board. Once the resistor is securely soldered in place, we use a multimeter to check if everything is properly soldered and if the resistance value of the resistor is correct. We measure the resistance, and if everything checks out, we can proceed to test the board. It's essential to check that all parts of the boost converter are properly connected before applying power. Sometimes there might be a break somewhere on the board, rendering all the work useless. This is a crucial step in the boost up circuit. So now, I'll explain why a diode might fail or break. And this is the second part of the issue with the boost up circuit. If a diode burns out or fails, there is typically a short circuit at the output of the step-up converter. This could be caused by either a faulty LDO or the board being shorted somewhere, especially if it has been crushed or dropped. However, the short circuit often occurs directly at the output, typically involving these two capacitors. With a rosin and voltage inject, we'll identify which capacitor is causing the short and replace it with a functional one. We'll replace both the capacitor and the diode, ensuring to observe the polarity of the diode and thoroughly clean the board. After verification, it's crucial to protect the board with a suitable adhesive or anti-corrosion spray. I typically use a plastic spray designed for this purpose, which can be easily removed during future repairs. That's all for now. See you in the next video. Don't forget to hit that like button, subscribe for more electrifying content, and share with your fellow tech enthusiasts.